Okay, now that we've covered transposition, let's move on to the other one, which is what we call inversion. And the label we're going to use for this, it looks very similar. It's going to be TNI. We're going to put the I in there for inversion. And then we're eventually going to figure out what the N is. So TNI, that means inversion. Now, I wish that inversion was going to be as easy as transposition, but unfortunately, it's been one of the most challenging kind of subjects for music theorists to deal with, how to label inversions. And, you know, it's just going to be a lot more difficult to understand this topic. So listen carefully here as I give you first some background on kind of what inversion is. Then I'll give you kind of the shortcut for what you need to do essentially. But it'll be good to know, you know, what's really going on here so you can at least have a little bit of conception of it. Now, first off, let's go to what you're probably familiar with in terms of inversion. So here I've given you an example of a pitch inversion. So I've taken the note, the little line B, D, E, which is +3, +2, and then I've inverted it. I've just taken it upside down, right? Inversion means to kind of flip something upside down. So the inversion of that particular idea would be would go -3, -2, as opposed to +3, +2. So that's what we mean by inversion in general. So if you ever saw this in music, that would be a pitch inversion. Now, as was true for transposition, composers can have fun though, and they don't have to musically realize it in such an obvious way. So I just reordered the notes over here to the right from the original ones. Those would still be inversions, even though you really can't tell at all from the musical presentation. It's kind of disguised there. Anyhow, just to start off with, inversion, essentially what we're doing is we're taking an idea and we're flipping it upside down. What about from the pitch class standpoint? All right, now let's talk about what the definition would be of inversion from a pitch class set theory standpoint. It's a little bit fancier. So the definition here would be reversing the intervals of a set by flipping the pitch classes around an axis of inversion. Okay, you probably remember that from Bartók. So Bartók is one composer who likes to use inversion a lot. So again, this is reversing the intervals of a set by flipping it around an axis of inversion. All right? Let me show you now. What I'm going to show you now is not how I'm going to eventually tell you to do this, but I just want to show you what that definition means over here on the clock face. So let's say I'm a composer and I have a set 10-0-1. I put that up on the clock face and I want to invert it. Now what I need to do as a composer is figure out what axis I want to invert it around. And there I can choose any axis. Remember how with the axis of symmetry it can go between notes or it can go through notes. Here, just for practice, let's say I'm going to choose the 5 to 11 axis. Ooh, sorry, let me get a... Sorry, I wanted to draw that with a ruler. All right, so going through 5 and 11, that should have gone through the note 5. Anyhow, so what is this going to mean? Basically, what I'm going to do is I'm going to take every note in my original set and I'm going to move it kind of equidistantly to a spot in the other set around the axis of symmetry. So if I'm choosing this right here, what I'm going to want to do is I'll take this. I will use open squares for the other set. So the number 10 equidistantly around this line of symmetry I've drawn would be the number 0. So we kind of get that number again. Then the number 0 would go over here. Probably should have chosen a different axis of symmetry for this one. And then 1, you'll notice this one is 2 steps away from my line. So it's going to go all the way over here. Therefore, the inversion of this would be 9, 10, 0. Probably should have chosen a different axis of symmetry so we didn't have so many of the same notes. But again, the idea was to flip all of these to the other side of the axis the same distance. So this one over here This went over here, and this note here went over here, right? So, but that's essentially what it means to invert a set. Now, the question is, how are we going to label all of this? This is way different than transposition when the label was so obvious that we were just going to say how far you moved all the pitches. So now we're going to get into sort of how we're going to do this. It just so happens that pitch classes that balance around the axis, that is the inversional partners. So like over there, the 10 and the 0 and the 1 and the 9, they happen to sum to the same value. In fact, let me show that again to you. So 10 and 0, those were inversional partners in this one, and 9 and 1, those were inversional partners. Notice that the integers of those pitch classes, they happen to sum to the same value. Here the sum is 10. It's just a mathematical convenience, actually, and kind of a useful thing for labeling is that the inversional partners, if I sum together the pitch classes, they happen to be the same thing. So that's actually what we're going to use. We're going to use the sum. So again, pitch classes that balance around the axis will sum to the same value, and that's what the n is going to be. So labeling for inversion, n is going to be the sum. What we just saw there would be an example of T10I. So it's kind of abstract. It doesn't have the same meaning as transposition. Like it doesn't really, the sum, in other words, doesn't really tell you how much work you had to do to get from one set to another set. It just tells you kind of what the axis of symmetry would be. To get that, by the way, you'd have to take the sum and divide it by 2, but you don't need to worry about that. Okay, so again, we're going to use the sum. So instead of an interval, the n is going to be the sum. All right, so now let's go ahead and talk about what you would need to do if you were going to be asked to invert a set. All you need to do is to create the indicated sum. Therefore, take your original set and with whatever each note, create the indicated sum. Mathematically, you'll subtract the integer from the sum. I usually just think about creating the sum, though. For example, T5I of 2, 4, 5. I'm going to get that answer, T5I of 2, 4, 5, I'm going to create the sum of 5. So I'm going to find the other number that would sum and create 5. Therefore, 2, I have it over here. So to create the sum of 5, 2, you would need 3 to sum to 5. 4, you would need 1 to sum to 5. And 5, 0 to sum to 5. And again, these right now are a new set. I'm creating a new set right there. So the answers I got here are 3, 1, and 0 to create those sums of 5. Now, then what I need to do, if I want to get the normal order, I need to reverse these. The normal order of this would be 0, 1, 3. So if I want you to put the answer in normal order, what you'll do from there is you'll just write those numbers in reverse, and that will be the normal order of the set. So again, all you need to do here is create the indicated sum. As weird as it sounds, it gives you the answer. So let's do a little practice now. I've got 2 examples right here that I want you all to work on. I'll pause the video for a moment and let you get the answers to these. So again, create the sums and then reverse them to get the normal orders. Okay, so in this first example, what you should have gotten is I'm going to create the sum of 3. So 1 and 2 will create the sum of 3, 3 and 0, and 4 and 11. And then to put these in normal order, I reverse them, 11, 0, 2. And there you go. And then for this one, I'm going to create the sum of 9. So 2 and 7 will create 9. 3 and 6 create 9. 5 and 4. And 7 and 2. And then if I want to put this in normal order, I just write these in reverse, 2, 4, 6, 7. And there we go. So again, as strange as it sounds, this gives you the answer to invert the set. You just create this sum that's asked of you. And essentially, if you were going to show what this meant musically, each of these sums would indicate a particular axis of symmetry. And we basically be flipping it around that one, but it's not actually the 3. That's the weird thing. It's actually 3 divided by 2. So this would be 1.5 would be where we would draw the line of symmetry. But like I mentioned, I don't really need you to do things that way, but that will be the more musically relevant one. Okay, so now that we know how to invert a set, now let's go on and talk about the analysis idea. Like how do you, if you're looking at two sets, how do I know their inversions? And then also, how do I know what the answer is? How do I know what the sum is if I'm looking at two sets? All right, so just like with transposition, sometimes you'll notice this in pitch space. So if the musical idea is truly inverted, literally in pitch space, you can avoid all the writing of integers to get the answer immediately just by summing together the corresponding integers in the idea, the musical idea. What I mean by that is if I took this example, so this was an example of a pitch inversion, right? And all I have to do is sum this and this, sum this and this, and sum this and this. These are the corresponding notes in the idea, and you should get the same thing. So now I'm thinking about integers. So 11 and 6, that would be 5. 2 and 3 would be 5, and 4 and 1 would be 5. Therefore, this must be T5I. So if you're encountering a musical situation that is a literal inversion, you don't need to write all those normal orders up and so on. You can immediately go to the answer. But of course, we can't count on this, right? Composers might do something kind of weird and disguise the relationship. So let's say you don't have the musical presentation to rely on. Now let's talk about what you would look for in pitch class, from a pitch class standpoint. And here again, the normal order is going to be the helpful thing. If the sets are inversions of each other, the normal orders will have sets with the same interval series, but in reverse order. I'm going to skip this next point for a little later, because this is an exception to this. Now, if this is the case, if you have the sets with the same interval series, but in reverse order, then you're going to sum together the notes from opposite ends of the normal order. All right, let me show you what I mean, because that sounds a little bit confusing. So, for example, if I look at these two sets right here, and let's say I know that they're both the same prime form, and I want to see if it's a transposition or inversion, you'll notice that the interval series of this one is 1, 2, 2, whereas the interval series of the other one is 2, 1, 1. So 1, 2, 2, and 2, 1, 1. So they're kind of palindromes of each other. That would tell you that we must be dealing with an inversion, because remember that intervals are going to be flipped. So right, so you'll notice that the interval series are the same, but in opposite order. 1, 2, 2, and 2, 1, 1. Whoops, I think I made a mistake there. That will be 1, 2, 2, and 2, 2, 1 right here. That should say 2, 2, 1, but don't worry about it. All right, now what you do, this is the last point. What do you do in this case? Now you're going to sum together the integers from the outside in, essentially. So I'm going to now sum 2 and 3, sum 3 and 2, sum 5 and 0, and sum 7 and 10 together. And you should get the exact same answer for each case. So here 2 and 3 is 5, 3 and 2 is 5, 5 and 0 is 5, and 7 and 10 is 5. Therefore, your answer is, just by coincidence, T5I. All right. So in the case of figuring out the relationship between two inversionally related sets, you just sum the integers from outside in, and you should get the same answer for each one. That will be your answer then. Okay, let's do, sorry, I wanted to mention that this little, unfortunately, boy, it would be nice if that was always the case. But occasionally, you're going to get a situation where the normal order will not immediately show this relation. For example, the sets 8904 and 81104, you'll actually find out that even though those are inversions of each other, they actually don't have the same interval series in opposite order. If that happens, so in other words, like this one has 1, 3, 4, whereas this one has 3, 1, 4. So those are the same numbers, but they weren't in reverse order. So here what you would need to do is you need to either, I would probably say the best thing to do will be to shuffle the notes around in the second set until you reverse the interval series of the first set. Let me show you what I mean. So you'll notice again, my original set was 8, 9, 0, 4. So again, this is an exception, everybody. And like I mentioned, the intervals here were 1, 3, and 4. Now, if I want to do all that same thing I did with the other set, I need to now take this set here, because it doesn't have that in reverse, and find some way to order these pitches so that it goes 4, 3, 1, but in this direction. So I want to see 4, 3, 1 above this other set. 4, 3, 1. These are the intervals, by the way. So let's see if I can figure this out. Oh, here you go. If I start with 4, 4, 8, whoops, I need to write this differently. Sorry, a little difficult to do this with the phone. 4 to 8. Then the 3 would be the 4 to the 11. And then the 1 would be the 0. That is how I can reshuffle this normal order into another one that will allow me now to sum the integers from the outside in. And so here, 8 and 0 is 8. 8, 9 and 11 is 8. 0 and 8 is 8. 4 and 4 is 8. And therefore, this is T8I. Anyhow, this usually doesn't happen, but unfortunately, there are larger numbers than we would like, really, for where this happens, where you're actually not able to go from the normal order. It would be really nice if that wasn't the case. There is another concept out there called best normal order that allows this not to happen, but that just seems like too many labeling systems. Okay, anyhow, so again, that was a more complex one. One of the ones down here for practice will have that situation. I'll just tell you from the start, the first two of these for practice will be straightforward. This last one, you're going to need to reorder things. So let me give you all now a little time to work on these three examples. You're figuring out the T, whatever I. You're figuring out what the sum is for these pairs of sets. Again, the first two will be straightforward. Last one's going to be more complex. So I'll pause the video. You all can work on this, and then we'll look at the answers. Okay, so summing from outside in for the first one, I see sums of 6, so T6I. Here, summing from the outside in, looks like 0 in each case, so this is T0I. Remember, this is mod 12, so there's no such thing as 12. 12 would result in 0. All right, now, unfortunately, the last one, you'll notice here, 4 to 3 is 7, 5 to 0, not 7. Oh, so something's wrong here, even though these actually are in normal order. So if I look at this set here, the interval series is 1, 1, 2, 2, 3. What I need to get is an interval series that goes 3, 2, 2, 1, 1, but in this direction, right? And let me see if I can do it. So 3, nope. I think if you start with 3, so 3, 2, 2, 1, yeah. If I start with 3, if I reorder this set as 3, so let me check this again, 3, yep. 3, 6, 8, 10, 11, 0. That allows me to reverse this interval series, and now I can do my summing. 4 and 0, 5 and 11, all the way down the line is going to be T4I. So hopefully you won't encounter too many of those, but they do occur. All right, so there's a basic description of inversion.